All right, example 3 of finding tangent lines using implicit differentiation. I know in the last example, if you saw that video, that I said that this would involve some trig. It does not. The one I had originally planned did involve trig, but it ended up not working out. So we're going to use this equation instead, which does work out. So, finding the tangent line of the curve given by the equation x to the 2/3 power plus y to the 2/3 power is equal to 2. And we're going to try to find the tangent line at the point 1, 1. The key thing to notice is that I do not have a function of like y is equal to f of x or x stuff in this case, but that's okay because implicit differentiation will allow me to find the slope of the curve at this point anyway. So how do we go about doing this? Same way we've gone about doing basically all of these implicit differentiation problems. Let's first put some parentheses around our y stuff, and let's get to it. Let's find the derivative with respect to x of both sides. So we have x to the 2/3. We're going to derive that, meaning we're just going to pull down the 2/3 in the front, subtract 1 from the exponent. So when we do that, that gives us x to 2/3, x to the minus 1/3, because we're subtracting 1 from the exponent. And then we need to take care of the second term. So how do we handle that? We're going to derive it using the exact same idea, except we need to use the chain rule here. So we have 2/3, that's going to get pulled down in front, subtract 1 from the exponent for starters. So we have 2/3 y to the minus 1/3, but we're not done because we have to multiply by the derivative of the inside, this y here. So we need to derive that, that's y prime, and that derives the second term. So now, on the right-hand side, the derivative of 2 is just 0. So we're in good shape here. Sure, you could turn these negative exponents into radicals in the denominators, but for the sake of our purposes, we don't really care too much about that because we're going to end up plugging in this point 1, 1 anyway. So that's an aside, but right now what we need to do is get y prime by itself. So our y prime stuff is right here. Everything that's not y prime stuff is going to get subtracted from both sides. Okay, rewriting, this gives us 2/3 y to the minus 1/3 times y prime is equal to minus 2/3 x to the minus 1/3. All right, so we have all of our y prime stuff on the left-hand side, just as what we needed. And then the last thing we need to do is divide both sides by this thing. Okay. All right, so this gives us y prime is equal to minus 2/3 x to the minus 1/3 over 2/3 y to the minus 1/3. And now we can cancel some of these things off a little bit. So notice that we have a 2/3 in the top and a 2/3 in the bottom. These kill each other, thus leaving us with minus x to the minus 1/3 over y to the minus 1/3. Again, we could flip these things around a little bit, but it's actually not going to be really all that useful to do that right now. So we have our y prime. That is our slope of our tangent line. This is the formula that's going to give you the slope depending on what x and y values you plug in. So now we have this point that we are given. We're going to plug this point in to our slope formula to find our m at that point. So we're finding m at the point 1, 1. So to do that, every place you see an x, you're going to replace it with the 1. Every place you see a y, you're going to replace it with a 1. So at the point 1, 1, y prime is equal to minus 1 to the minus 1/3 over 1 to the minus 1/3. 1 to the basically any power is always going to give you 1. All right? So what this is going to give you is minus 1. All right? Because the 1 to the minus 1/3 power, that's just 1. Same thing in the denominator, leaving you with just minus 1. Okay, so that's our slope at this point. We're halfway there. So now we need to find the equation of the tangent line. All right, to do this, we need the point slope form, which is going to be y minus y0 is equal to m times x minus x0, where your x0 and your y0 are a point on your line. The point that we are given is what goes into your x0 and your y0. So 1 and 1 go here, and then your m is the thing we just found. So you replace everything that you have here with that, so you have y minus 1 is equal to minus 1 times x minus 1. You take your minus 1 and then you distribute. So you have minus x plus 1. That implies, trying to get y by itself, y is equal to minus x plus 1 plus 1. I just added 1 to both sides. So this is minus x plus 2. And that is your final answer. Y is equal to minus x plus